Hey, what's up guys? This is Zihan. So today I'm going to talk about Kirchhoff's voltage law, which is also known as KVL. First, let's give a simple description of what is Kirchhoff's voltage law. Kirchhoff's voltage law states that the sum of voltage drop along a closed loop in the circuit is equal to zero. As shown on the right-hand side diagram, we have the sum of voltage drop is equal to zero, and that's also the mathematical expression for Kirchhoff's voltage law for a closed loop. Let's go for a further analysis of why this is right. How about the sum of voltage drop does not equal to zero? Assume we have diagram on the right-hand side here, a circuit with a voltage supply 9 volts together with 3 resistors in series. Each of them has a resistance of 100 ohms. The current in this circuit can be calculated easily using Ohm's law, 9 volts on 300 ohms, which is equal to 0.03 amps. And assume the sum of voltage drop in this circuit does not equal to 0, which means there must be a voltage drop somewhere on the wire. But for an ideal wire, it has no resistance, means the current in this particular part of wire will be infinite large, and therefore does not equal to 0.03 amps. So the result here is absolutely wrong, and it means the sum of voltage drop has to be equal to 0. So in the last part of this video, we're going to do some questions using KVL. So we have a question here, calculate Vx in the circuit diagram shown on the right hand side. To solve this kind of problem using Kirchhoff's voltage law, remember the first thing that you always have to do is to choose a loop. So in this problem, I decided the loop to be clockwise here. And the second thing we have to do is write down the formula, which is the sum of voltage drop is equal to 0. So here we have the sum of voltage drop equals to 0, and thus we have minus Vx minus V1 plus V2 minus V3 equals to 0. And the next step is just to substitute the values. So here we got minus Vx minus 1 volts plus 6 volts minus 3 volts. Notice here it's minus 3 volts. And the last step we have is just to calculate Vx. Here we go. Vx is equal to 8 volts. Simple and easy. That's basically how you use Kirchhoff's voltage law to solve problems. So thank you for watching this video. Hopefully you understand what is KVL and are able to use it to solve problems easily.